In just 2 short months, we helped over 55,000 Canadians find a vaccine within driving, walking, or transit distance to them. We had over 7,000 vaccination locations for first and second doses updating every single minute. We had tens of thousands of page views every single day and 15,000 emails being sent out every single morning. This entire system took 1 week to make. I make Canada's vaccine locator. I'm going to tell you exactly how I did it. When the vaccines finally became available in Ontario, there was a serious problem. There was no one central location to try to find an appointment for you. That meant that you had to go and scavenge across like 10 different websites for Shoppers Drug Mart, Walmart, grocery stores, public health, random nonprofits to try to find an appointment time that worked for you and was as soon as possible. This meant that people spent hours scavenging and looking on these websites trying to find an appointment that was close to them and was also soon enough that they could get it. And that also meant that sometimes they would book at one place, and if there was an appointment sooner at another, they would cancel that one and then move to another one. It caused a whole bunch of confusion. Even worse, the appointment system made it so that if you were to book something and cancel last minute, they would have taken your vial of vaccine out already, and it would have been sitting out there and gone to waste unless there happened to be somebody walking by that wanted to get jabbed that day. So we created a website that took all of those different websites for Shoppers, for Costco, for Walmart, for the nonprofits, for public health, aggregated all the data into one readable format and presented it on a simple dashboard. This meant that you could go to our website and find all of the inventory and appointment information for all of these different websites without having to look at them individually. This saved you a bunch of time and helped people find the ones closest to them. Now, of course, there's a catch. These individual websites had no interest working with some random person like me. So what did that mean? That meant that we had to do everything a little janky. The system was split into 3 different parts. You had the user-facing front end, which was the dashboard that they would go and interact with. You had the data aggregation and indexing back end, which was Java. They would never see be running on the servers. And you had the data fetching workers. These are the ones that would go to all the individual websites, fetch the data by scraping it, and then send it to our back end. For the user-facing front end, we wanted 2 different systems there. We wanted one that was a dashboard that you could just visit, type in your postal code, and find all of the available appointments near you, the sites that you can go to book the appointment, and how many vaccines they had available. The other system was an email notification system that allowed you to type in your postal code and receive email notifications about available vaccines near you at 9 a.m. and 4 p.m. every single day. This meant that the back end was really split into 2 distinct parts when it came to the front end. There was the data aggregation and indexing that was presented in the dashboard, and of course a system that ingested postal codes, converted it to some amount of data that we were able to then index and compare against the available sites nearby every single day at 9 a.m. and 4 p.m. and then blast out the email with that information. The backend also needed the ability to ingest the information from these different websites and convert it into one type of data format that was readable throughout the entire system. It didn't matter if the information was coming from Shoppers Drug Mart or Costco or Walmart or public health. It could read that information, ingest it in a readable format that then could be used in all these other systems without having to try to translate it or make sense of it manually. And that brings us to the other side of the equation, our data fetching workers. These data fetching workers were running on Python, and they had to be able to go to these websites, get through whichever sort of security, whether it be Cloudflare or DDoS protection or something like that, to be able to access the website, scrape the data minute per minute, and report back to our server. This was probably the most challenging part of all this because a lot of these websites would change the security, change the way they were operating, change sort of the dynamic features on the website that we were scraping from. This really proved to be the most difficult part of the system. My partner and I split the work into what we were best at. He's really great at doing all the data scraping and everything, so I let him handle that. I'm really good at the front end and the back end, and that's what I focused on. I knew the front end could be very simple. It was essentially just a list that was displaying data from REST APIs from our back end. So the front end was super simple. I did it in vanilla HTML. I wrote my own CSS and my own JavaScript, all very, very simple. No reason to make it complex. I was using Spring Boot for the back end to host all of our REST APIs and do all the processing because I'm very familiar with Java and I love it. And I used Apache Kafka to do all the asynchronous processing that was required once the data fetching workers reported back with the information that they scraped, or when somebody went onto the website and signed up for email notifications. We were using Postgres as the main database server, and our Spring Boot application, along with Apache Kafka, fed directly into that and read directly from it. All of this was running on a single FreeBSD machine that I was hosting in a data center nearby. So let's talk about exactly what would happen when one of our data fetching workers reported back with information that it scraped from one of the providers. It would report back the location of the vaccination site, the available appointment time slots, how many vaccinations were available at each time slot, and what the vaccination type was. It would then call a REST API on our Spring Boot backend, which would then ingest all of the information directly into Apache Kafka. And this is where we started having the stream processing handle the indexing and placing it inside of Postgres. The first thing this Apache Kafka asynchronous process would do is it would take in the location and compare it against a table inside of our database to find the location ID. Once we had this location ID, we were able to upsert it to a table inside of the database that stored all of the appointment information. Upsert means that it would either update if it already existed or insert if it was new information. This allowed us to have one central location with all the vaccination appointment information that we were then able to correlate to a table with all the location names and the longitude and latitude of that location. Once that information was fully indexed and inside of that table, it was then prepared and able to be displayed on the dashboard. So let's talk about how a user would interact with that information. The first thing they would do is they would visit our website and type in their postal code in the dashboard. This would then send a request to our backend with their postal code, and we would convert that to longitude and latitude. We would use that longitude and latitude and draw essentially a radius circle around their location inside of our SQL query. We would then use that statement to query the database and find any vaccination locations within that radius circle and then present that on the dashboard. The radius of that circle was dictated by a little slider that we had on the front end that allowed them to signify to our system how far they were willing to travel for a vaccine. Once the query returned all those vaccination sites, we would clean up the data and we would send it back to the front end to be displayed in a nice dashboard. We then had the other side of the front end, which was the email notification system. This was a simple form that just ingested their information, like their postal code, their email, their first name, and how far they were willing to travel for a vaccine. This would then send all that information in a request to one of our REST APIs on our backend, and Apache Kafka would ingest that information and then follow basically the same principle as the dashboard. We would take the information, we would draw a little circle around it using that radius that they selected, and then we would find all the vaccination sites within that location. We would save it to a database, and those would be the locations that we queried every single day at 9 a.m. and 4 p.m. for their email. We would then rerun that same query to find all the vaccination sites in that circle every single day at 11 p.m. for every single user, just in case there were some new locations within that radius bubble that they could go visit, whether it be a pop-up or a new permanent location. This meant that all the information was fresh as it could come, and it was showing up every single day at 9 a.m. and 4 p.m. Once we had finished all the work and the system was ready to go, we posted it on the internet in a few different locations, and it instantly blew up. We got well over 10,000 page views in the first day. We had tons of people signing up for email notifications. We had people using the dashboard and finding locations that way, and it was fantastic. We received a lot of great comments on places like Reddit and Twitter, and we received a lot of emails from people thanking us for setting up this service and making their life a little bit easier. Once the system had been running for a couple hours, we started getting approached by people from the media asking to do stories on it and asking to promote the service to other provinces. This, of course, lit up a light bulb in our heads, and we decided to expand this to all of Canada. This meant that we had to go and adapt the system for every single province and territory in Canada, which did everything completely different naturally. About 1 week in, we ended up having Saskatchewan, Manitoba, Quebec, and Ontario in the system, and we were working on the rest. Nonprofits from around Canada started reaching out to us and asking us to set up basically their only web presence to let people know that they had the vaccines, and that was pretty freaking cool. After a few more days of work, we ended up having all of Canada and well over 6,000 vaccination sites, and constantly growing every single day. The system was able to ingest information from brand new sites and add the locations automatically to our system. This meant that a lot of our manual work was done now. We didn't have to do anything and the system would just run. Now that's not to say that there weren't problems. There was definitely a lot of things that we had to stay up very, very late to fix and maintain, and a lot of it had to do with the data fetching workers because, like I said, a lot of these websites would change how they were doing it. They would change the security, they would add Cloudflare or DDoS protection, and they would make it extra difficult to get that information, but we were still able to make it work. Looking back, it honestly feels like it went by in like the blink of an eye, but I'm very grateful that we did it. We had a fantastic time. I don't regret any of the late nights. I had a lot of fun. I was able to help a lot of people and I felt great doing that. And I'm hoping that you guys enjoyed me talking about this. If you guys want to see more videos like this, I'm definitely going to do more stuff with system architectures and talking about how to design big scale systems. If you guys are into more classical engineering stuff, I actually have a video on my channel already about building a rocket engine in my garage. That was really cool. It was my first video. You should definitely go check it out. Anyway, thank you very much. I appreciate it. I hope you'll subscribe. Take it easy.